All right, so what we need out, folks, are our notes from yesterday so we can finish them. You'll also need your packet because we're going to do some practice questions together in a minute. And then some pens and pencils. I did grade the lab you turned in yesterday. You'll see the grade in Aspen because it was on paper. So that it doesn't go in Google Classroom for you to see the grade. Just like all your other labs, you have the opportunity to correct it, but not during class time. If you want to correct your lab to earn half the points you lost back, you just have to arrange a time to come in and see me and fix it in this classroom. Okay? Before school, after school, free periods, lunch, study hall, that kind of thing. I cannot get you out of a class, and I will not let you do it during class time because this is now extra. Okay? So if you want to correct it, you can see your grade in Aspen, you can see what you got, and you can come on in. Just tell me when you're coming. And if I need to write you a pass to come down from study hall or lunch, I'd be happy to do that. I'm either in this room, I'll tell you where I'm going to be. I'm either here or I'm in the office next door. Someone else is teaching in this room, I have to be next door. You can't correct it in this room. All right, so where we left off yesterday, if I remember correctly, looking at my notes, this is where we left off talking about all this stuff. These are my notes from yesterday with our position time graph and our velocity time graph. And we talked about how to make this graph from this one. Yes. And I asked you to study this last night because we're moving on from this. So before we actually try some practice questions, I want to try to see if you can summarize the patterns that we've learned or should be recognizing now related to both types of graphs. Okay. So we're going to make a summary chart, if you will, which you can use to help you study. And you can even make yourself flashcards if you want. But this is the pattern. How do I figure this out on this type of graph? Kind of break it down. So let me show you how I want you to break this down. Where are my other notes? Where I have the pattern. Right here. Okay, let's make 3 columns. It's going to be a fairly big chart. The middle column is going to be how can we determine this on a position versus time graph? The far right one would be the same thing, but for a velocity versus time graph. And on the left, I'm going to be listing the different characteristics like how can we determine the velocity on each of these graphs? I'm using a ruler. You don't have to be that OCD about it. Then secondly, what would it look like if you are moving fast on each of these graphs? What would it look like if you were moving slow on each of these graphs? What would it look like if you are moving to the right on each of these graphs? What would it look like if you were moving to the left on each of these graphs? What would it look like if you had a constant velocity on each of these graphs? And I think the final one, the last one is what would it look like if you were not moving on each of these graphs? And we're going to use our notes to help us do this. Okay. Let's use our notes to help us do this. All right, so I want you to think about it. Let's start with velocity. And let's go back to position time graphs. That's what we did in section B of this unit. How do we find the velocity on a graph of position versus time? Yep. The slope is equal to the velocity. You should know that. Now I want you to think about yesterday's lesson. We didn't do any calculations yesterday on a velocity time graph. How do you determine the velocity on a graph of velocity versus time? Yeah, so you just read the y coordinate. Just read the y coordinate, because on the y-axis are the velocities. So the y values are your velocities. Okay, so now let's think about if you're moving fast. Let's talk about the position time graph. How will we know that an object is moving fast? It's very steep. Let's do the slow then, which is the opposite of that. If you're moving slowly on a position time graph, Olivia, it is shallow. That is correct. Let's keep going. If you're moving to the right on a position time graph, how do you know you're moving to the right? Emily? What's positive? Yep, so it's a positive slope. The graph goes up, in other words. What about if you're going to the left? That's right. This graph is coming down. It has a negative slope. Now, let's say you are moving and you have a constant velocity. What is that graph going to look like? I'm not saying it's fast or slow, right or left. I'm just telling you that you are moving with a constant velocity. What is the graph going to look like on a position time graph? Do you know? It is a diagonal line. That is correct. And if you are not moving, meaning your position is not changing over time, that's right. This is your horizontal line. All right, so now let's go to the new stuff from yesterday. Review, and you may want to look at the velocity time graphs that we made yesterday. Let's think about if you're traveling fast. Right, didn't we have this graph here yesterday? How can I tell if I'm traveling fast? Which right now are graphs. Can you tell me which of these we're traveling the fastest? Jules? 3 and 5. How can we tell that? I agree with that here, but 5 is not. What could I say about both of these? It's right. In other words, their y coordinate without the sign is as big as possible. So they are as far away from the zero velocity as you can get. Doesn't matter whether it's positive or negative. The number without the sign is how fast it's going. So the faster it's moving, the further from the time axis the value or the velocity is. The further, just say further from the time axis. That's how we get large velocity. What about if you are moving and you're going slow? So let's look at this one. Can you tell me which of these is moving and slow? Yeah. Yes, and how can you tell that? Yeah, they are closest to the zero value. So your speeds are small numbers. So this would be close to the time axis. Remember, the time axis is a zero velocity value. Now let's think about right and left. On this graph, which objects are moving to the right? And we had our descriptions of motion down here as well, so that may help you. Which ones were traveling to the right? Jack? I'm sorry? Yes, 3 and 2. How can you tell that? Yeah, they're above, up in quadrant number 1. That's right. They have positive velocities. And positive velocity values occur in quadrant 1, which is above the time axis. So let's now think about going left. Which ones were traveling left on this velocity time graph? Caitlin, can you tell me? Yes. And what's the same about both of those? Yeah. And do you remember what quadrant this is? Yes, quadrant 4. So that's where we have negative velocity values. That occurs in quadrant 4, and this is below the time axis. All right, let's now talk about if we're moving with a constant velocity. Which objects on our velocity time graph were moving with constant velocity? No, not all of them. They were actually moving with constant velocity. Jack? Yeah, all of them but 1. So what's the same about 2, 3, 4, and 5? I'm sorry? Yeah, and they're all horizontal lines that are not on the time axis. So if you have a constant velocity, if you're moving with a constant velocity, you have a horizontal line that isn't on the time axis. In other words, you have a non-zero y coordinate. Now, 1 was the only one that wasn't moving. How could we tell that? Yeah, so it's a horizontal line on the time axis, or where the y coordinate equals 0. That's what you're looking for. Okay? That's a summary of what we learned yesterday and the previous week. Let's now keep your notes out to help us go to page 17 in our packet, where we're now going to do some practice questions about this. All right? So keep that out so you can look at it, because I doubt anybody just has this boom, 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 where you could just spit it out. Not yet. You got another week or so to figure all of this out for sure. Tomorrow we will quiz on this. And your homework for tomorrow, we're going to do page 17 and 18 now, but your homework for tomorrow is pages 19, 20, and 21. 19, 20, and 21. Okay, 3 pages on the same stuff, just to make sure you can practice this all together on your own, and then we'll go over it before we take our quiz tomorrow. 19 through 21. All right, so let's take a look at this. I want you to sketch graphs of velocity time that correspond to these descriptions of motion on these axes here. Okay, so let's look at the first one, which says that the object is moving away from the origin. I want you to add something to this. say to the right. It's moving away from the origin to the right at a constant, steady speed. What's that going to look like on this graph? What should we sketch? Cam? I agree with that because that means we're moving to the right and it's horizontal. That's right. So a horizontal line up in our positive velocity quadrant because positive means we're moving to the right. What about number 2? The object is standing still. What does that mean if we say you're standing still? You're not moving. What does that mean your velocity is if you're not moving? What is your velocity? 0. So what's that going to look like on this graph? Alex? Yeah, and what shape is it? Yeah, horizontal line on that time axis. Because that is where you have a 0 velocity number. All right, number 3. The object is moving toward the origin, let's say, to the left. So it's traveling to the left, which is toward the origin, at a steady speed for 10 seconds, and then it stands still for 10 seconds. So that means we need some time on here to help us out. How much time is involved in this question, Nick? How much time? A total of 20 seconds. And obviously we have a break point at 10 seconds, and then we have another over here at 20 seconds. All right, so we're going to have 2 different graphs, one from 0 to 10 seconds and the other from 10 to 20 seconds. What's going on from 0 to 10 seconds, Cam? Okay, and so how do I show that it's to the left, going left? Which quadrant is moving to the left? 4, negative. That's what left is, negative. And if it's going at a steady speed, what do I graph? Josh, what am I going to graph if it's moving at a steady speed or a constant speed? Horizontal line in this quadrant. Just until we get to 10 seconds. Then what happens at 10 seconds? Okay, so what's that going to look like? Yeah, horizontal line at 0 right here. So this is where you're headed to the left. That's where you've stopped. Make sense? Yep. Okay. Number 4. The object is moving away from the origin, let's say, to the right at a steady speed for 10 seconds, and then it instantly reverses its direction and goes back toward the origin at the exact same speed. Let's say, again, this is a total of 20 seconds. So I'm going to label 10 seconds and 20 seconds. And of course, there is a 0 velocity. So if we are traveling to the right at a steady speed for 10 seconds, what's that going to look like? Takari, can you tell me? Yep, where? Where do I put it if I'm going to the right? Yep, up in quadrant 1. And that's just until we get to 10 seconds. Because then at 10 seconds, now we have to reverse our direction, which means now we're going to go which way? Yeah, left. And if we're at the same speed, what should I make sure I'm doing? not only do I want to put it down here, but to show it's at the same speed. Yeah, so the same distance away from this axis, but here. So if this is +5, what's the number, the y coordinate right there? -5. Okay, that would be the same speed, just the opposite direction. So instead of it being positive, it's negative. Does that make sense, everyone? You're cool with that? Okay, let's go to the next page. The next page is a little more precise because we're going to do some calculations, but the math is easy, so I don't believe you need a calculator to do this. First thing I want you to know or notice is that in the left, I'm giving you a graph of position time. We want to then put the velocity time graph that matches this motion here. But do you see how there's numbers on it now? And there's numbers here. So it means we actually have to figure out what the velocity is for this object so we can plot it here. How do you find the velocity on a position time graph? What did we say we have to do? You can look back at that summary chart. Addie, what did we say we have to do to get our velocity on a position time graph? Yep. How do I find the slope? So let's review that. The slope on a position time graph equals the velocity. And remember how you do a slope, it's rise over run. How much does it go up divided by how much does it go over? So let's look at this graph, and I'm just going to label the slope on the line. How much is this graph going up? This line goes from 0 to 4. So how much did it go up? How much is it going out? What's 4 divided by 4? See, you didn't need a calculator to do that. So this velocity is equal to, is it positive or -1? Okay, so +1 meter per second, meter over seconds. And that's all the way from 0 to 4 seconds. Do I know what's happening between 4 and 5 seconds? No, I don't. Do you? Why don't we know? There's nothing there on the graph. So we're not going to be able to plot anything here from 4 to 5. We can't assume. So we just have to go from 0 to 4. And the value that we're going to plot is +1 at every single time point. So +1, +1, +1, +1, +1. So what's that graph going to end up looking like? Horizontal line. You did not have to put those data points. I was just showing you how you get it. Horizontal line at +1 from 0 to 4 seconds. Everybody follow? All right, let's go to number 6. We got to come up with slopes again on this graph. How many slopes are we going to have to find? 2, because we have 2 different lines. So let's do the first one. From 0 to 1 second, how much is it going up? 2 over what distance? What's 2 divided by 1? Positive or -2? Okay, so I'm just going to write +2 meters per second. Let's do the next line. How much is this line going up? It starts at 2 and ends at 4. So it's going up how much? 2 over what time? 4. What's 2 divided by 4? A half. Is it positive or negative a half? So positive 0.5 meters per second. Y'all follow that? Make sense? All right, so the +2 is just from 0 to 1 second. And then the positive a half is from 1 to 5 seconds. Does that make sense, everyone? Did I lose anyone? We're good with that? All right, then here's what I'm going to do. I'm freezing my screen. I want you to do number 7 right now on your own, and then we'll compare. Okay? You guys ready to check it? Everybody done? All right, let's just look at your position time graph first. Did you label the velocities on it? Positive 1 meter per second and negative 2 meter per second? Yes, did you get those slopes? Okay, so positive 1 from 0 to 2 seconds, horizontal line. And then a horizontal line at negative 2 meters per second from 2 to 4 seconds, not to 5, right? It only went to 4 seconds. We don't know what's going on from 4 to 5. How many of you got that question correct? Yay. So that means you're understanding what we're doing. Good. All right. So your homework is the next 3 pages for tomorrow. What we're now going to do, everyone's going to need their Chromebook now. And you can see that we are now going to do a lab for the rest of today in class. Lab number 6. It is a virtual lab. I should say it's an online lab. Virtual makes it sound like it's not a real lab. It is a real lab. It's just an online lab. So everyone is going to need their Chromebook for this. Give everybody a minute to get the Chromebook out. I'm going to do part of the lab with you to show you how to do it. And then I'm going to break you up into smaller groups. And you're going to work in your smaller groups to try to finish up as much as you can in class today. All right. And then whatever you don't finish in those groups, notice that you'll need to finish it up for homework. But I suspect most of you will probably finish this in your groups during the double period. All right. So the lab that we want to open is lab number 6, which is called the Moving Man Lab. Lab 7 also uses the same simulation. So we're going to learn how to use it today. Excuse me. Open it up. And I have to make a copy of it because I don't want to edit my main file. My template that I push out to everybody. Everybody have that open? Yeah? Okay. I just want to caution you guys. I see a lot of you have water bottles out next to your Chromebooks. That can be a little dangerous. I hope you understand that. Okay. I'm not responsible. You electrocute the circuitry in your Chromebook because you spill your water. It's not my fault. It's on you. All right. So what we're going to do in this lab, you can see you are exploring position and velocity time graphs for objects moving with constant velocity, which is what we've just been talking about, right? So we're going to get to see objects moving with constant velocity in different ways and make the graphs. Google Sheets will help us make those graphs. So you'll see in the setup on our first tab, folks, that there is a simulation called the Moving Man FET. Go ahead and open up that simulation by clicking on it. It will take a moment for it to open up. So we have to wait as it opens. The same website we'll be using in the next lab as well. And when it opens, it looks like this. Everybody good? Okay, so I want to show you a couple things. It does say in the lab that there are 2 tabs in the lab, Introduction and Charts. That's right here, Introduction and Charts. We don't care about the charts section. Go to the Introduction tab. That's the whole lab is done in this, okay? And then we want to play around with it to find some things. So I'm just going to show you some features. First of all, do you see this large meter stick that the guy is on? He's at the 0 meter position right now. And I can see it's 0 meters because in the position box, it's reading that value. I can move him around on that meter stick by either clicking and dragging him around. Or if I want to click on the position bar, I can click and move him around that way too. Or I could type in an exact position for him to go to, like 0 meters. And that moves him right back. I can also adjust his velocity, meaning how fast he's moving and in what direction, by typing in a value like positive 1 meter per second. Notice now he's moving to the right at a constant speed of 1 meter per second. Or I could stop his motion with the pause button, come back to the velocity. Let's say I make it negative 1 meter per second. Take a look at what happens. When I hit the play button, now I see he moves to the left at that constant speed of 1 meter per second. You'll see you have a record and playback button here because it will be recording data for you. If I then want to play it back, I click the playback button and hit play, and it will then show me everything I just did. Yo, you see it? It's showing me. If I want to replay it in slow motion, take a look. I can adjust the slider bar down to slow motion. If I stop it and hit play, now I'm going to see it in slow motion of what's going on. But I can actually have it clear everything out. What would I do to clear everything? Reset all. That's right. Go ahead and hit reset all settings. And that puts everything back to where we started. Okay, so that's how we're going to play in this lab with what we need to do. Is everybody okay with that? You've got the controls there to do what you need to do. All right, let's come back into our Google Sheet, and we're going to go to part 1. I'm going to do part 1 with you. And then I'm going to break you up into smaller groups so that way you can do parts 2, 3, 4, and your conclusions together in your groups without me walking you through it. So let's look at part 1 first. All the parts are done pretty much the same way. Did we reset all of our man's values to 0? Did you? Okay. Now it says, make sure you set his position to 0 meters. Mine's already at 0 meters. But then I want you to give him a velocity of 0.5 meters per second. So let's come into the PhET simulation, change his velocity to 0.5 meters per second. Everybody did that? All right. Now it says, click the play button to start him moving until he hits the wall on the far right, and then hit the pause button to stop the recording. So let's go ahead and do that. So I'm going to hit the play button. You see it's recording. You see the record is in red. We want to let him keep moving until he gets to that brick wall on the far right. Twiddle my thumbs until he gets there. And boop, he hit it. He stops. I'm hitting the pause button. Okay, y'all understand what we're doing? All right, now let's go back into our Google Sheet. What does it want us to do now? Now it wants you to use your playback feature so that way we can record, not in the simulation, but in this chart, the man's position and velocity data. Don't adjust the decimal places. So what I'm going to do is start at time 0. And if I look at this, I have to go back to time 0. I hit the playback feature. And if I hit play, whoops, let me go back. I want to go to a time of 0 seconds. See, here's 0 seconds. The position and my velocity. I have to write down or type those numbers in my chart. All right. So what I'm going to do when I go to my Google Sheet, the position was 0.021 meters. Notice it truncates it to 0 meters, 0.0. That's okay. And the velocity was 0.5. Now I'm going to go back into the simulation and play until I get to 1 second. And I can actually use, when I hit play, I can actually use my left and, or which one actually allows me to step it through? These buttons here, the rewind and fast forward buttons, allow me to do it. Shoot, where was it? Play. There it is. And you can actually adjust it by just clicking this. This will step it forward. You see that? You see which button I'm hitting? That will step it forward at like frame by frame kind of thing. If I need to go back, this resets it all the way back. So I can just also just adjust my slider bar until I get there. So at 1 second, oops, there I am. You get, I'm using 0.479 and 0.5. Notice it's going to truncate the positions, and that's okay. All right, now go to 2 seconds. Let's do the same thing. And 2 seconds. There it is. 1 meter and 0.5. 1 and 0.5. Now I'm going to move him to 3 seconds. There it is. 1.479 and 0.5. 4 seconds. Do the same thing. I know it's kind of tedious. I'm sorry. 1.979 and 0.5. We'll go to 5 seconds. Do the same thing. 2.479 and 0.5. 6 seconds. 2.979 and 0.5. 7 seconds. Notice that when I type in my numbers, I don't put any units after them. If you do that, you won't be able to make your graphs. 3.5 and 0.5. Go to 8 seconds. There it is, 4 and 0.5. 9 seconds. 4.479, 0.5, and finally 10 seconds. 4.979 and 0.5. Okay, everybody good? All right, so now here's where I have to show you how to change things up, because the graphs that we need to make are not going to come up the way we want, and we have a fair amount of customization to do, especially because I have a 3-column data table and I only need 2 columns to make a graph. So let me show you what we're going to do. In step 5, it says make a graph of position time. We need to put our best fit trend line on there and the equation for it, and put your graph in this yellow space. All right, so here's what I want you all to do. You see where I have time in seconds and position in meters? Hold your shift key down. You see the time in seconds is highlighted in blue. Shift, right arrow over to position. Now down arrow, keep your shift key, keep it down. So that way your times and your positions are highlighted. So do you have that blue highlighted box like me? We're good? All right, insert, chart, whoops, insert, chart. It's not going to give you the right type. I don't know why, it just doesn't. Do you remember what type of chart we need? Anybody remember? Scatter, the one on the left, scatter. All right, so double check something. Your data range should be B5 to C16. Is it? B5 to C16 in this data range box. The x-axis should say time in seconds. The series should be position in meters, and that's it. Okay, notice we don't have a title. The x and y axes are not labeled. We have to add all of that stuff. Go to the Customize section of the chart editor, please. The titles and labels for the axes are under Chart and Axis Titles submenu. So expand that. My first option is Chart Title. This is a graph of position versus time. So we have to type that in, position versus time. Can you all see on my screen well enough? Or should I make this bigger? No one's saying make it bigger. So position versus time. Now click that down arrow and go to Horizontal Axis Title. On the horizontal axis, we have time in seconds. It then adds the label. Then let's do our vertical one, and then we'll take our break. The vertical axis title is position in meters. Okay. Once you have that, take a break. When you come back, we'll keep working on this graph and the next one and the questions on this tab. And then I'll turn you loose. I'm going to click and drag this down. Mhm. All right, let's continue. All right. So everyone has this graph constructed like mine on the screen. We're not quite done with it. Notice again, we added the title, position versus time. We added the title on the vertical axis, position in meters, and the horizontal axis, time in seconds. Always double check that you have a clear 0, 0 on the graph. Not a data point there, but you can see it on both axes. I can see it on both of mine. Can you see it on yours? Okay. Now we have to add the trend line or best fit line or curve to this graph. Do you remember where that is under this customize section? Under series. All right, so I'm collapsing the chart and axis titles menu. Expand the series menu, and we're going to do two things here. We're going to select trend line first. Does the linear fit look good to you? Yeah, so stick with linear. But now head down and under the label, click the down arrow and say use equation. You need the equation on the graph. Should look something similar to mine. It may not be exactly the same, but something like 0.5 times x plus almost 0. This number is really small. We may not get the exact same equation, and that's okay. All right, everybody good? All right, now the next graph is harder to make. So I'm going to go slow. Pam?
You don't need to change the stuff about the equation?
No.
Oh.
No, you just leave it the way Google Sheets gave it to you. Okay. Now let's head down to step 6. Make a best fit graph of the velocity versus the time from the data in step 4. This gets tricky because the velocity and time columns are not adjacent to each other. So I'm going to show you the easiest way to do this. Head back up to your data table. Put your cursor so the time cell is highlighted in blue like mine is. Do you have that? Okay, hold your shift key down. Right arrow over to velocity and then down arrow to select all the numbers. It's okay that we have all 3 columns highlighted. It's okay. I'm going to show you how to fix things in a minute. Everybody good? All right. Go to insert your chart and it's going to be the wrong type. We have to take under the set chart editor in the setup, change the chart type to the same we've been using, which is scatter, the option on the left. Now here's where your data range should say B5 to D16. Does it? Okay. The x-axis, it should say that we have time in seconds on the x-axis. Yes? Okay. But look under series. It's showing us both variables right now being plotted on this graph. We only want one of the 2 being plotted. Do you remember which one we want on this graph? Velocity. So we got to get rid of position. And let me show you how to do that. On the right side of where it says position, you see we have these 3 dots and your cursor changes to like the pointer finger on it. Click that, click the 3 dots and say remove for position. And now position has been removed from the graph, and all we have on it are the velocity data points. You see? Okay. Now what I want to do is customize this again because it doesn't have the title, the X or Y axes labeled. It doesn't have the trend line or the equation. So we go to the customize section of the chart editor and go to chart and axis titles. Let's start with our chart title. This is a graph of velocity versus time. So go ahead and type that, add that to your graph. Everybody good? All right, now click that down arrow. Let's go to the horizontal axis title. This should be time in seconds. The vertical axis title will be velocity in meters per second. All right, I'm going to collapse this submenu and now head to the series submenu because I can see the clear 0, 0. So I don't need to adjust my horizontal axis. Click on the series submenu. We're going to add our trend line. Default is linear. How does that look? Does that look like a good fit? I think so. And now where do we add the equation? Under the label, say use equation. Beautiful. Now you have to click this graph and drag it down into the shaded space under question 6. All right, so I have to move it. Click and drag it down, please. Just like your position time graph, you had to place it in the right spot on your Google Sheet. Place it in that shaded region underneath question 6. Click and drag. It's kind of a pain in the butt. Okay? That's why it says place your graph in the space below. Otherwise, I have to, when I'm grading this, I got to move stuff all over your page, and I don't want to do that. You should be doing that so we can see everything. All right. Everybody have the graph? All right. Now we're going to answer some questions before we continue to part 2. So according to the graphs, first question asks, what is the shape of the position graph? So let's look at the position graph, which is this one. What is the shape of that? It is a diagonal line. All right, so the position graph is a diagonal line. You can type that in there. The position graph is a diagonal line. Now, what is the slope of our position graph? So the slope, remember, is the value in front of the x, and we can approximate it, round it out to 1 decimal place. What is that slope? About 0.5. Now, what units does this slope have? Meters per second. So we're going to add that to our answer. So the slope of this position graph is 0.5 meter per second. Right? Approximately 0.5 meter per second. Hit enter, so you're out of that cell. It saves your answer once you hit enter. A lot of you turn in Google Sheets to me, and then I say that the box is blank. It didn't save your answer because you didn't move out of the cell after you typed it. Once you move out of the cell, it saves it. Until you do that, it's not saved. All right, part C. Why does that answer, or doesn't that answer, make sense? That 0.5 meters per second makes sense to me. I want to see if you can tell me why it makes sense. Ready? And what was the man's velocity in this experiment? There you go. So the slope makes sense because it was or is the man's velocity. That's right. His velocity in this experiment was 0.5 meters per second, and that's what the slope was. All right, we ready for part D? What's the shape of the velocity graph? So let's look at that graph. What is that? It's a horizontal line. All right. So the velocity graph is a horizontal line. Now, does that make sense that it's a horizontal line? It does. Can you tell me why? What does the horizontal line that isn't on 0 mean? Yep. The shape makes sense because the man's velocity was constant. Okay? That's how you do each part of this lab. And then once you do, notice that all we're doing in the other parts of the lab, part 2 is the same thing, but you're giving them a different velocity. And notice it says this is going to be a fast constant velocity to the right. Part 3 is the same thing, but now he's going to travel at a slow constant velocity to the left. Part 4 is the same thing, but he's going to move at a fast constant velocity to the left. And then once you're all done, you've got some fill in the blank questions to answer on the conclusions tab, to look at the patterns. Okay? Now, I want you to work in groups on this, so that way, I would suggest, one person in the group collects the data for part 2. Another person collects the data for part 3. Another person collects the data for part 4. Just get the data and then share your data with everyone else, so that way you don't all have to go through and do the PhET simulation 4 times. We already did it once. You only have to do it one more time yourself. And then you can work on making your graphs all together and answering the questions all together. Does that make sense? That's probably the best use of your time. All right, so we have 19. Yes, Emily? Yep. I'll keep that right there for you. So what I will do is I want to put you in groups, unless you want to place yourself in groups. You can work in a group of 3 or a group of 4. A group of 4 doesn't make a whole lot of sense because there's just 3 more parts to do. But if you're in a group of 3, one person does each part. If you're in a group of 4, 2 people have to do one part together. Okay? Do you want to place yourself in a group? I don't want you working by yourself. You're not going to have, otherwise you're not going to finish probably this class period. I want you to try to finish this class period. So you can get up and move. You may need your notes to help you with the conclusions. Okay? And if you get stuck, guess what you do? Yes, raise your hand. Miss Famoso, can you come over and check this, please? Or I can't figure out how to make this graph. Or is this answer right? I think it's this, but I'm not sure. Okay, you ask. All right, I'm going to turn you loose to get this done. I'm going to stop my recording.